Today we're going to finish up the chapter. We're going to talk about symmetry and transformations. And I handed out these cheat sheets on symmetry and transformations and then a visual graph. I'm going to attach it with our notes today and send it to everybody. But this visual graph, when you work out that last time, is give me the answers, take a picture, send it to me to remind, and we'll do that. So everybody will get a copy of it. Symmetry. What is symmetry? What is it? How would you define symmetry? It's a mirror image. If something is symmetric, that means it's equal on both sides. But how many sides does our mirror have? 3. What are they? We have 3 symmetries. The first one is about the y-axis, meaning the graph rotates about the y-axis. When we say about the y-axis, that's what it rotates, about the y-axis. Then we have one about the x-axis. And then the last one is about the origin. But really doesn't flip like that. If it's about the origin, that means it flips across the x-axis and then flips across the y-axis. It does them both. So how can we tell if a function is symmetric about the x-axis, y-axis origin? Let's look at this. We have a point at 1, 2. That's point 1, 2. If it's symmetric about the y-axis, then we have a point -1, 2 that is the mirror image of it. So if it's about the y-axis, what's the only thing that changes? The x. So if we start off with f of x and we get a y value, then if we put the same number in there but negative and we get the same y value, then it's symmetric about the y-axis. In other words, the only thing that changes is the x from positive next to negative x, and the y value stays the same. And if we had a point at 1, 2, and it's symmetric about the x-axis, then we have a mirror point at 1, -2. Only thing it changes there is what? The y value, because the x's stay the same and the y values change signs. So for this one, if I have f of x and it equals y, and bless you, if I have the same x and I get a negative y, then it's symmetric about the x-axis. Is it a function? Why not? Can a function be symmetric about the x-axis? You know, I'm going to ask you why. No, the vertical line test, because it fails the vertical line test, so it's not a function. So if I had a point 1, 2, and it's symmetric at the origin, then there's a mirror image at -1, -2. So with this one, both values change signs. So if I had a point at f of x equals y, then if I put the negative x in there, I get the same value, but different signs. That's how you can tell if it's symmetric about the origin. So far, so good. Now, these have names. If it's symmetric about the y-axis, where the only thing changes is the x value, we call that an even function. If it's symmetric about the origin, or if I change x from positive to negative, then the answer changes. It's the same numbers, they just change signs. This is what we call an odd function. And neither if it's in the middle, because it's not a function. If it's symmetric about the x-axis, it's neither, because it's not a function. So I'm going to show you mathematically how to determine these, and then I'll show you a shortcut where you don't have to do any math. So f of x equals x squared plus 3. I give you any function. I'm going to ask you, is it even, odd, or neither? So first step, choose an x. And in that case, also the same number opposite side. Plug them into the function. If you get same number with the same sign, then it is even. It's an even function. If you plug it in there and you get same number with different signs, then it is odd. If you get different numbers, it is neither. Right? So let's pick a number X. Let's say 2. So we're going to look at 2 and -2. So f of 2 equals 2 squared plus 3. 4 plus 3 equals 7. F of -2. Whenever you input a number inside an equation, it's safer if you put them in parentheses first. I'll tell you why in a second. So what's -2 squared? -2 times -2 is +4, plus 3 is 7. So we get the same answer, same signs, so it's even. Look at another example. F of x equals 2x cubed plus 3. Is it odd, even, or neither? Odd, even, or neither? Neither or neither. Follow the same that we did last time. What's 2 cubed? 2 times 2 times 2 is 8. 2 times 8 is 16. 16 plus 3 is 19. So that's the first one. Then we do the same thing with -2. So it's 2 times -2 cubed plus 3. What's -2 cubed? -8, right? -2 times -2 times -2. We have a positive times negative is negative. 2 times 8 is 16 plus 3. They're opposite signs. 16 is bigger than 3, so the answer is going to be negative. 16 minus 3 is 13. So what do you know? Yeah, since they don't equal, it's neither. How about 2x to the fourth minus 3x squared? What's 2 to the fourth? 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. 2 squared is 4. 2 times 16 is 32. 3 times 4, 12. 32 minus 12. 20. Now the same thing with negative 2. Negative 2 to the fourth. Positive 16. Negative 2 squared. Positive 4. 32 minus 12 is 20. They're both the same, so it's what? Even. They're the same number and same signs, so it's even. X cubed plus 2x. So first one's 12. What did you get from negative 2? So negative 2 cubed is negative 8. So 2 times 8, so positive times negative is negative. 2 times 2 is 4. Negative 8 minus 4, they're both negative. 8 plus 4 is 12. So we have the same number, but different signs. What is that? What is it? Odd. Because you have the same number, different signs, it's odd. It's another one. F of x equals negative 5. So at positive 2, what is it equal? At negative 2, what is it equal? It's a constant term. So is it odd, even, or neither? Even. Because the y values keep the same value. All right, let's look at those that we've just seen. The first one was f of x, x squared plus 3, and that was even. The second one was f of x, 2x cubed plus 3. That was neither. The third one was f of x, 2x to the fourth minus 3x squared. That was even. X cubed plus 2x, and that was odd. And the last one, that was. So let's look at this. What can we notice? Let's look at the even ones. What do we notice about the even ones? Even ones, if they're just constants, they're even. Or if all the powers are even, then it's even. Or if we combine the even exponents and the constants. So it's even if all exponents are even and or there is a constant term. So it's even. When is it odd? The only one we have odd is only if they're odd exponents. Only if all exponents are odd. No constant term. Actually, there's supposed to be one more we're supposed to do. But if we had 3x cubed plus 2x squared, this would be a neither also. I'll prove it to you in a second. So we have 3, 2 to the third, plus 2, 2 squared. 2 to the third is 8. 2 squared is 4. 3 times 8 is 24. Plus 8 is 32. -2 cubed is -8. -2 squared is +4. Positive times negative is negative. 3 times 8 is 24. Plus 8 is -16. So it's neither. Again, if you notice if you can find a pattern of something, then it makes life much easier for you. So when is it? So it's even. It's even if all exponents are even and you have a constant, or if you have a constant, doesn't matter. But constant numbers are always even. So they can only match with even exponents. Odd exponents only can match with odd exponents. They cannot match with even exponents, or they cannot match with constants. They're neither if there are mixed exponents or odd exponents and a constant term. So either they're all even or they're all odd. And the only time you can have a number in it is with evens. Because an even function looks like what? What's the graph of a constant function? So this equation, f of x equals -5, what does that graph look like? It's a horizontal line, which means it flips across the y-axis. So that's symmetry for you. And just by looking at it, you can tell me how it behaves. Even functions flip across the y-axis. Odd functions flip across the origin. Neither usually just flips across the x-axis, but it could be anything that's not either of those. Pretty straightforward. So all you do is look. You don't have to do any work. Just look at the equation. Look at the exponents. If they're all even, then it's even. If they're all odd, it's an odd function. If it has a number at the back, it can only match with even exponents. That's all there's to it. So basically I saved you the time from having to do this for larger equations. So that's that section. So that's section 4.